Welcome to 2020 higher level question B3. It's a perspective question. So the image on the right shows a monument to deceased members of the Irish Defence Forces. So the figure here shows the plan and elevation of a pyramid based on an image on the right. A pictorial view is also shown of the structure. Okay? Draw the given plan and make a perspective drawing of the given structure or of the structure given the following. The spectre is at S, so back there at a 6-degree angle, 3.3 meters from corner A. So here's a corner A. The picture plane is touching corner A, so our picture plane is going to be there on A somewhere. And our horizon line is 3 meters above the ground line. Okay, looking at the question, we've got a scale 1 is 30. Okay, I've converted all these measurements already, but just to show you how I did that very first one, 3.3 meters. So 3.3 meters, okay, is 3 meters or 330 centimeters. Okay, we deal in millimeters when we're doing any drawing, so to convert that to millimeters, we multiplied by 10, so that was 3,300. And our scale then is 1 is to 30, so I divided by 30. Okay, so that gave me 110 millimeters. So that's going to be the distance that I use for the position of my spectator away from corner A at that 6 degrees. I've also converted all the other measurements. You can do in your, yourself before you begin the question. So we'll start out anyway by drawing our plan view of the pyramid. So up here, top right corner, I'll draw a line. Okay, and the length of one side of our pyramid, because I converted it there, is 112. So 112 millimeters. So draw my square base, 112. Join the diagonals because it's a pyramid. That is the basic square base pyramid shape. And here is our corner A. Okay, now we need to add in all these divisions the way it's split up there. So each one of those is 0.42. And I converted that to 14 millimeters. And we've also got a 0.21, which is 7 millimeters. So I'm just going to mark off all those and draw them lightly for now. So 14 plus 14 is 28, plus 14 is 42. And that's it, kind of my 7 there, millimeters. I've got another 14. I'll do the same from the other side, or just actually continue on. You can go 7, 14, 32, 14. Okay, equal divisions. I'll just draw those lightly. Now I could measure those measurements up along here, but we've got a diagonal which is bisecting, say, imagine there, with a square shape. Okay, so it's bisecting. So I could measure all those if you want again, but just to be quicker, I'm actually going to take those measurements along here to get my points. Okay, and now just to heavy in the lines that need to be heavy here, so taking care not to make any mistakes with this. Okay. Okay, so that's my plan. And I also asked this actually here, this point C is my flag, so it's a point view there of the flag, so I must also locate that. So I'll extend my diagonal and measure out 20. So that's my point C there. Okay. Just adjust the camera so you can see that. There you go. Okay, so let's find my spectator. We say that's going to be 111. That's the position of my spectator there. Yes. Okay. So setting up question, same always. It's a handy way to pick up marks. You just need to know the procedure. So we join the outside points and bisect that angle to find a perpendicular bisector, which will in turn give me the position or the angle of the picture plane. So here's my bisector. Okay, we know that the picture plane will tell us in the question that it passes through corner A, so I'm going to set up my sliding set squares here and slide back, and my picture plane will be here. Okay, So that's the plan view of my picture plane. Now let's find the vanishing points. So vanishing points are going to be parallel to the edge of the object. Vertically then parallel again to the edge of my object. So that's our picture plane. And that's our VP2, and here's our VP1. Okay, now I'm going to just pause the video and rotate my page. So now I've rotated my page so that my picture plane, okay, is my kind of horizontal line. I'll just make life easier when I'm projecting between views. So we need to find the horizon line and the ground line. Right? They tell us that the horizon line is 3 meters above the ground line, so that's 10 centimeters, okay, or 100 millimeters. So let's project down my VP1 and VP2. So my ground line and my horizon line is 100 up from that. So look, it's going to be intersecting or crossing over my spectator, but I just have to load that to fit on the page. Okay, so my horizon line and my ground line. VP2, VP1. Okay, so my corner A is resting on the picture plane, again it's on the ground, so I can bring that straight down. Okay, and I'm going to vanish that back to my VP2 and VP1. I can bring down where the outside corners hit the picture plane. Bring them down. So that'll give me a heavy edge there. And there. Okay, I suppose the next most important point would be the top of the pyramid, if we can get the overall pyramid shape. So that point, bring it back to our spectator where it hits the picture plane, drop it down. So it's going to be somewhere there along that line. And now we don't have a position of it, but we do have the height, okay, of that pyramid. So we've got a height of 120, so we need to take a height line out for that. Okay, I'm thinking that we'll take a height line here, okay, parallel to our edge there, or to our edge, parallel out, hits the picture plane, drop that down. We can take our actual height of 3.6 meters or 120 millimeters up here and vanish it back. So let's do that. Sliding set squares. We've got a height line, so it hits our picture plane, and drop that down. That height then, we said, is 3.6 meters or 120 millimeters, so measure off 120 millimeters, and a height line, and vanish that back to our VP2. Okay, and that intersects our line coming down there. So that is going to be the height, or the apex of our pyramid. Let's go. Okay, so I suppose next what we want to do is we want to start bringing down our divisions. We'll start with these ones here. So where it touches the picture plane, bring that down, and center this. Where it hits that diagonal, we can find where it's the diagonal, or the edge there also. So so that comes down and hits our diagonal is about there. Join the two of those up. And vanish that back also. Set back there, I'll use that later. So that is a diagonal going up there. Okay, and that is going to be the same height as that, so that's why I vanished it back, and it's at the same height running across this face, so vanished back. So that's found me another point. We just need to find the base again. So to the spectator, find those divisions, drop them down to my edge from the picture plane. And join them up. Okay, so now we just need to find these horizontal, well, what lines are horizontal in reality. Okay, so we can bring down, that's what I'm going to do. I'm going to bring down these points until I hit my spectator, where they hit the picture plane, and drop them down onto that edge and vanish them back. So I might actually do that from this edge or this edge, just because like the margin for error is kind of high here, because everything's going to be quite tight to each other. So I'm going to do it from here. That one I've brought down already. And there. And there. So we'll bring them down onto our edge. And last one. And I can vanish those. My VP2, and shift them forward. We can send them back to VP1 then also. Okay, so that's the outline of my shape. And we can just double check, yeah, it looks like the pictorial view there. Okay, so next up they want us to find the flag. Oh, have we actually done the flag? True shape of the flag located in position C in the elevation. Did you mention anything about this? Yeah, so it's just the structure in A. They're looking for the flag now in B. Okay, so let's find the position of C in our perspective. So we have C here. Found it earlier on. Let's bring that back to our spectator. It hits the picture plane, drop that down. Okay. Now the base of C, we can see it's in line with if we extend it on our diagonal. Okay, it should be in line with that. Yeah, so if I, just to show you in the graphic here, if I extend it on that diagonal through to there, that will find the base of the flag. So we'll do that. Okay, so my flag is going to start here. The height of the flag then is at the same height as the actual pyramid. Okay, but we're dealing with a different plane for that, so I'm going to have to take a separate height line for that. Okay, so I'm going to extend out a height line along here until I hit my picture plane, so I'll extend out my picture plane and drop it down, and I'll take natural height there because the height line that I've currently got doesn't contain point C. Okay, so I need to use one that's containing point C. Okay, so just extend on a picture plane. Okay, so it's great. Let's cross point C. So my height line. I equally could have brought one down this direction as well, but I suppose it's just clear out to the side. Okay, so the height of the flag we can see is 120 to 3.6 meters, and then the distance down to the bottom edge there of it is 0.9 or 30 nanometers. So let's take those measurements. So 120, now we'll come down 30. Okay. Pretty long distance to cover there. Okay, so if your set square isn't long enough, you've got a longer one here, I'll get it now. And you could, like I said, you could just have taken your height line into here and dropped it down. Same thing achieved. So you can see I've vanished those heights back. Here's my C coming down. So that. It's going to be height of the flag, and we've got points there and there. That's going to be where that's the flag pole, and we're going to have to find where the flag itself goes from there. So if we look at our flag, okay, they say that it has an angle of 30 degrees. Okay, so let's just read the question. I should have read it earlier. The true shape of the flag located at position C shown in the elevation. We have that. Flag is the shape of an equilateral triangle. Okay, so that's great. we know that that would be in reality 60, 60, 60 if we were to draw this, okay, but we didn't have to. Draw the flag in the perspective view, draw the flag in the perspective view and then use an auxiliary vanishing point to determine the slope. Okay, so could possibly do this without it, but we are going to do it by using an auxiliary vanishing point. Okay, so 30-degree auxiliary vanishing point. Fine. If I want to see that flag, okay, so the flag is sitting here, okay, that 30-degree angle. Okay, that means I need to take an auxiliary from this side. Okay, if I took it from this side, all you see is an edge view of that triangle there, so the 30-degree angle wouldn't be relevant. So let's measure our 30 degrees from our spectator. Okay, it's more or less on that line running back. Okay, so just need to extend this line back. It's a 90-degree triangle, 90 degrees, or 90-30, because it's essentially like this, rotating down. Okay, so 90-degree angle. So use my sliding set squares here, set up a 90-degree angle. So that is the height there to my auxiliary. Okay, a triangle drawn, right angle triangle. So get the height, okay, from my VP2. I'm going to step it up from my VP2 and swing it down also. Okay, so that's what came up a little bit there, just about fits in. So extend this up so we can look at the exact position of that. So here's my auxiliary. So from this auxiliary VP, I can draw through the position at the top of my flag, and from the bottom one, I can project through the bottom point of the flag that I have. Right, I'll draw those in here now. Okay, so that is the solution there to the B3, question 2020. Okay, a nice perspective question on that here.